NEC Section 450.3 states that in addition to the provisions of this section, transformers shall comply with the applicable provisions of Articles 430, 450, 490, and 500. NEC Section 490.9 requires a fusible disconnect on the secondary side of a transformer if the overcurrent protection for the transformer is not provided by the primary overcurrent protection. This means that if the primary side of the transformer doesn't have adequate protection to handle overcurrent situations on the secondary side, then a fusible disconnect is required on the secondary side. The purpose of a fusible disconnect is to provide a means to quickly and safely disconnect the transformer from the load in the event of an overcurrent or fault. This helps to protect the transformer itself, as well as the equipment and personnel connected to the secondary side. A fusible disconnect is a type of electrical switch that uses a fuse to interrupt the flow of current in the event of an overcurrent. When the current exceeds the fuse's rating, the fuse melts and breaks the circuit, disconnecting the load from the power source. This type of disconnect is often used in applications where a high level of protection is required, such as in industrial settings or in critical infrastructure. The location of the fusible disconnect is also important. It should be installed in a readily accessible location so that it can be easily operated in the event of an emergency. It should also be located close to the transformer to minimize the length of the conductors between the transformer and the disconnect. This helps to reduce the risk of voltage drop and improve the overall performance of the system. Exception 2 to this rule states that no disconnect is required if all of the following conditions are met. Firstly, the secondary is protected by a single overcurrent device located on the secondary side of the transformer. Secondly, the overcurrent device is rated not more than 125% of the secondary winding rated current. Thirdly, the disconnect serving the secondary is not a readily accessible fuse switch or circuit breaker. This exception provides an alternative to using a fusible disconnect in certain situations. If all three of these conditions are met, then a disconnect is not required. However, it is important to note that this exception should only be used when it is safe and appropriate to do so. If there is any doubt about whether or not a disconnect is required, it is always best to err on the side of caution and install one. The first condition of the exception requires that the secondary is protected by a single overcurrent device. This means that there should only be one circuit breaker or fuse protecting the secondary side of the transformer. If there are multiple overcurrent devices, then this exception does not apply and a fusible disconnect is required. The second condition requires that the overcurrent device is rated not more than 125% of the secondary winding rated current. This means that the overcurrent device should be sized appropriately to protect the transformer from overloads and short circuits. If the overcurrent device is rated too high, then it may not provide adequate protection and the transformer could be damaged. The third condition requires that the disconnect serving the secondary is not a readily accessible fused switch or circuit breaker. This means that the disconnect should not be easily accessible to unauthorized personnel. This is to prevent accidental or intentional disconnection of the transformer, which could disrupt power to the load. It's important to understand the difference between the primary and secondary sides of a transformer. The primary side is the input side, where power is supplied to the transformer. The secondary side is the output side, where power is delivered to the load. The primary side typically has a higher voltage and lower current than the secondary side. The transformer works by using electromagnetic induction to transfer energy from the primary side to the secondary side. The ratio of the number of turns in the primary and secondary windings determines the voltage and current transformation. For example, if the primary winding has 1000 turns and the secondary winding has 100 turns, then the voltage on the secondary side will be 1/10 of the voltage on the primary side, and the current on the secondary side will be 10 times the current on the primary side. This is known as a step-down transformer. Conversely, a step-up transformer has more turns on the secondary side than on the primary side, which increases the voltage and decreases the current. Transformers are used in a wide variety of applications, including power distribution, electronic devices, and industrial equipment. They are an essential component of modern electrical systems, and it's important to understand how they work and how to properly protect them. When selecting a fusible disconnect for a transformer, it's important to consider the voltage and current ratings of the transformer. The disconnect should be rated for the same voltage and current as the transformer, or higher. It's also important to choose a disconnect that is suitable for the environment in which it will be installed. For example, if the disconnect will be installed in a wet or corrosive environment, it should be rated for that type of environment. In addition to the NEC requirements, there may also be local codes or regulations that apply to the installation of fusible disconnects. It's important to check with the local authorities to ensure that the installation complies with all applicable codes and regulations. The purpose of overcurrent protection is to protect electrical equipment and wiring from damage caused by excessive current flow. Overcurrent can be caused by a variety of factors, including short circuits, overloads, and ground faults. Short circuits occur when there is a direct connection between two conductors of different potential. This can cause a very high current flow, which can quickly damage equipment and wiring. Overloads occur when the current flowing through a circuit exceeds the circuit's rated capacity. This can cause the equipment and wiring to overheat, which can lead to insulation breakdown and other problems. Ground faults occur when there is an unintended connection between a conductor and ground. This can cause a current to flow through the ground path, which can be dangerous to people and equipment. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of current in the event of an overcurrent. Fuses are one-time devices that melt and break the circuit when the current exceeds their rating. Circuit breakers are reusable devices that trip and interrupt the circuit when the current exceeds their rating. Both fuses and circuit breakers are available in a variety of sizes and ratings to protect different types of equipment and wiring. When selecting an overcurrent protection device, it's important to consider the voltage and current ratings of the circuit being protected. The device should be rated for the same voltage and current as the circuit, or higher. It's also important to choose a device that is suitable for the type of load being protected. For example, inductive loads, such as motors and transformers, can draw a large amount of current when they are first started. Therefore, it's important to use an overcurrent protection device that is designed to handle these types of loads. The NEC provides detailed requirements for overcurrent protection in Article 240. This article covers the selection, installation, and protection of overcurrent protection devices. It's important to follow the NEC requirements when installing overcurrent protection to ensure that the electrical system is safe and reliable. In summary, a fusible disconnect on the load side of the transformer is required by the NEC under certain conditions. Specifically, if the overcurrent protection for the transformer is not provided by the primary overcurrent protection, then a fusible disconnect is required on the secondary side. There is an exception to this rule, but it only applies if all three of the conditions are met. When selecting and installing a fusible disconnect, it's important to consider the voltage and current ratings of the transformer, the environment in which it will be installed, and all applicable codes and regulations.